Okay, here we go. It's an amazing day. We're going to talk about some of the difference formulas of sine and cosine and tangent. Anybody want to give a shout out to somebody who's missing right now? Okay, Lisbeth.
Hi, Jessica.
All right, I guess Jessica got the shout out. Is that it? Gigi, wake up. Stop sleeping. Who else? Olivia. Olivia, we just got done watching 5 minutes of Office episodes. Joe, don't drink the water in Mexico. All right? Causes problems. Explosive diarrhea. All right, here we go. Some of the difference formulas for sine. We have sine of A plus B. Now, I'm going to write what it's not before I write what it is, because sometimes that's a fun game to play. I especially like it. Okay, so here's what it's not. It's not sine of A plus sine of B. A lot of people want to use like the distributive property of multiplication as though we're multiplying here. It's not multiplying, right? Like, what is the operation? The operation is sine. Sine is an operation in and of itself, just like multiplication is an operation, okay? So you can't do that. That's totally illegal, okay? So what is sine of A plus B? It is the sine of A times the cosine of B plus the sine of B times the cosine of A. The question why comes up. So I had never proved this before. And last year over spring break, I sat down and proved it, and it was really cool. Like, it was a challenging proof. I would show you guys. I'm afraid that zero of you would actually retain what was happening. A fourth of you might actually follow what's happening. It's rather lengthy and bulky, and it's very geometric-ish, and it's not good. So if you'd like to see the proof, you can check your book out, but we do get that, okay? But yeah, it's rather involved, rather involved. So yeah, if we subtracted it, we do subtraction instead. So what about cosine? Well, cosine of A plus B. Well, that ends up being cosine of A times cosine of B minus sine of A times sine of B. So what changed? Yeah, so the location, the signs and stuff, but also it switched to subtraction, right? So if it was subtraction up here, what would it be down here? Addition, and you can see, so it's probably the first time you've seen that symbol before. Instead of plus minus, you see a minus plus. So it's opposite what it was for the other one. You see that? It's kind of cool. It's like, oh, crossed a new bridge. All right. I'm sorry, guys. I'm in such a good mood. Like, I like tonight. Like, I get sleeping tomorrow. I'm gonna like watch Lord of the Rings and like, yeah, like Gandalf. I can't wait to see him. So I'm kind of geeking out right now. It's just spring break's coming and it's gonna be so neat. All right, sine of 15 degrees. So this is the big idea. We want to be able to evaluate sine of 15 degrees, and we want exact, folks, exact. Because here's the number one thing people do on a test. I give you 0 points for this. They press sine of 15 on their calculator, and they get like 0.25. I give you 0 points for that. Nothing. Nada. Because my daughter in first grade can do that. She can type sine of 15. She has no idea what it means, but she can do that. I'm not giving you any credit for things that my daughter can do, okay? All right? Like, she's a smart kid, but you guys are way smarter. No offense, Timley, okay? All right. So, but maybe there's two angles that add or subtract to 15 that I know the exact value of. Like, for example, do you know the exact value of sine of 30? What is it? Pi over 6 is the radian. What's the exact value of sine of 30 or sine of pi over 6? 1 over 2. So here's what Maydi did. He created this triangle, which you had on your final exam, right? And he created 30 degrees, and he said the location of that is the root of 3 over 2, 1/2. So he said sine is the y value, so it's 1/2. So there are two angles that either add or subtract to 15 that we know the exact values of. 45 and 30. Thank you, Grace. So we've got sine of 45 minus 30. Sweet. we're going to go back to example 1. I don't really like the order I put this in. Well, don't do sine of 45 minus sine of 30, right? Instead, we do sine of 45 times cosine of 30 minus sine of 30 cosine of 45. Awesome. Well, I've got a 30-degree angle there. I'll draw a 45 one just because it sounds like it's really a good time. So we've got root of 2 over 2 and root of 2 over 2, right? Yes? So what's the sine of 45? What's the cosine of 30? Root of 3 over 2 because it's the x value. Very good. Minus, what's the sine of 30? 1/2. What's cosine of 45? Root of 2 over 2. Sweet. So I got root of 2 times root of 3, which is root of 6 over 4. Because we multiply. Minus the root of 2 over 4, which is the root of 6 minus the root of 2 all over 4. And now we get to my favorite. Well, I got a lot of favorite parts of this lesson, but this is one of my favorites. So on my calculator, I go sine of 15, and I press enter, I get 0.2588. Sweet. But then I do parentheses, square root of 6 plus square root of 2, and I divide that by 4, and I get, oh, minus, sorry. Yeah, I was like, what's going on? And I get the same thing. That's exact, folks. This, I award you 3 points on the test board. Do you see how it requires you to know the exact value of sine and cosine? Do you understand why I asked you to do that on your final exam? So, although you may not use it in real life, I am trying to ask you things that are important for you to know moving forward. We leave it. Oh, no, look at letter B. Ugh. 7 pi over 12. My goodness, what? That would be like saying you could take, say, 5 squared minus 4 squared and say, well, that's 1 squared. Because the square root's a power. So, you know, order of operations says you have to evaluate the power before you do addition or subtraction. So, okay, cosine 7 pi over 12. Boy, I sure could convert that to degrees, couldn't I? What is it? Very good, 105. So what are 2 angles? Close, 5 pi over 12, 75. So that's all right. I made the same mistake this morning. So 2 angles that add to 105. This is the part you got to come up with this one. Like 60 and 45. Sure, we'll use those. So cosine of 60 plus 45. Well, we're not going to do cosine of 60 and cosine of 45. We're going to write out the formula. Exactly. So suppose you want to do 135 minus 30. You'll come out with the same answer. It's amazing. We could do both examples and prove it. Okay, you believe it. All right. So we got 60 and 45. So I've got cosine of 60. Cosine of 45 minus sine of 60, sine of 45. Do you know the exact value for cosine of 60? What is it? 1 over 2. Cosine of 45, for 2 over 2, minus sine of 60. Root of 3 over 2 times sine of 45. And I get root of 2 over 4 minus root of 6 over 4, which is root of 2 minus root of 6 all over 4. Is that similar to what we just had? Yeah, it is. Is that positive or negative, do you think? Why? Yeah, so root of 6 is bigger than root of 2. 105 degrees, is that in the first or second quadrant? Second quadrant, is cosine positive or negative? Negative, so we should get a negative result. See how I checked the reasonableness of my answer? All right, here we go. Sine of 23, cosine 67, cosine 23, sine 67. Shoot, I don't know what sine of 23 is. I don't know what the cosine of 67 is. I don't know any of that stuff. What do I do? Wait a minute. Eve, speak forth your wisdom. Well, slow down because we don't understand how insanely smart you are. Are you saying that it fits that form? So you're saying that it fits the form of sine of a plus b. What's a in this problem? 23. And what's b? Oh, you're right. 23 plus 67 is 90. What's the sine of 90? 1. Oh. It was, semi-impressive on Eve's part, was it not? Oh, we did the whole thing. This whole thing is sine of a plus b. Look at our formula up there. This whole thing is sine of a plus b. What we did is instead of going this direction and expanding it, we went that direction. We took this thing and made it into that. No, suppose it could be 24 and 66. Yes, 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 exactly. So suppose this was 22 and 68, then it would not have worked. Would not work. Hey, letter B, that looks semi-conspicuous as well. First of all, I want to convert it to degrees because the ratings are just freaking me out. Agree, Elizabeth? All right. 2 pi over 3, you know that one, right? 120. And I know that Jackson knows 5 pi over 12. It's 75 out of boy. So, we got that 120 and we got that 75. Well, does this look like a cosine formula or a sine formula? Cosine of a plus b or a minus b? A minus b, because it's opposite in sine. So that's the cosine of what is angle A? 120 minus 75. What's 120 minus 75? 45. What's cosine 45? Oh, that was easy. Look at how we just took a problem that looked really complicated and we made it into nothing. Not too bad, huh? You guys are almost there. We just got 2 examples left. Now we just got to do tangents. Yes. Tangent of a plus b. This one's super nice because it's just tangent of a plus tangent of b. Divided by 1 minus tangent of a times tangent of b. Notice how I did that pause for effect? Yep. Yep. So that's how I remember it. I remember the top is the same as how it's set up, like you would just distribute it. And the bottom just 1 minus the 2 multiplied together. Suppose it was a minus here. What do you think would be here? Minus, how about down here? So that becomes the formula. And that's exactly what you have written on your sheet of notes to use on the test. It won't make you memorize all the formulas. Though, if you'd like to accept the challenge of memorizing all the formulas, I encourage you to step up to the plate. So what you're saying is we should just get rid of half the class. Okay, all right. All right. Smaller classes are special, aren't they? Don't happen very often. But we'll hold on. All right. Find the exact value of tangent 19 pi over 12. How about I get rid of that 19 pi over 12 and convert it to degrees? Anybody help a guy out? 285, thank you. Wow, Eve, you are on the ball today. Pi over 12 is 15. Because pi over 6 is 30. Right? There you go. There's a connection. Oh boy, two angles that add or subtract 285. And this, folks, this is what you got to come up with this. We don't know 15. So 270 and 15 sound like a good idea, but we don't know 15, so that's out of the mix. Oh, that's a good idea. Could you use multiple angles? We don't know 75, so 75 does not work out. So 75 and 210, that's out. So gone. How about let's just start with one that you do know. Okay. 45. 45 and what? 240. Hey, we know those. That'll work, yeah. 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 How about this one? How about 150 and 135? Would that work? Yeah, it would, wouldn't it? How about 60 and 225? Would those work? Yeah. It's to your benefit to be able to come up with more than one, and I'll show you why. This is extremely important you guys follow this, because this is about making your work quicker and more accurate. Anybody here like to be slow? Okay, we all like to be faster with our efficiency and everything, right? Here we go. If you watch, and I consider a 60-degree angle, okay, I have a terminal point of what for a 60-degree angle? 1/2 and root of 3 over 2. So we consider 1/2 root of 3 over 2. How do I come up with tangent? Sine over cosine, so you do y over x, correct? So I get root of 3 over 2 divided by 1/2, multiplied by the reciprocal, and I get, so you can see that, if we have a 60-degree angle, we've got the root of 3, okay? If we use 225, 225 makes a 45-degree angle, so I have negative root of 2 over 2 and negative root of 2 over 2. So what would tangent be? 1, okay? So if I use 60 and 225, those are the two values I would end up working with. Now it's different. If you use 150 and 135, you end up coming up with these values. You come up with negative root of 3 over 3 and negative 1. So my question to you is, would you rather use the red values or the blue values? The blue values. And so the better you are at identifying terminal points, the more efficient you're going to be in selecting ones that work out better. Now, will you come up with the same answer here? Yes. But it's definitely a lot more work. So, you want to use the blue set? Okay, let's go to work. Tangent of 60 plus 225. Expand. Tangent 60 plus tangent of 225. Very good, Gracie. Divided by. Man, you guys are good. What's tangent 60? Is it? All right, cool. I guess we decided that, didn't we? Plus tangent of 225. 1 divided by 1 minus root of 3 times 1, which is root of 3. Can I leave a radical in the denominator? How do I get rid of a radical in the denominator? When you don't know how to do math, do Spanish. Yeah, you multiply by the conjugate. 1 plus root of 3. I wonder when people watch YouTube videos, they just think we're a bunch of idiots when we say, when you don't want to do math, you do Spanish. It's like, sorry. It's kind of a joke. I don't think it's funny, though. Maybe I should have like a GoFundMe page attached to the YouTube video. I could make like $1 or something. All right. Root of 3 times 1 is root of 3. Root of 3 times root of 3. 3. 1 times 1. 1 times root of 3. over what? 1 minus 3. So I do the top, and I get 4 plus 2 roots of 3. And what do you have in the denominator? Negative 2. Is everything divisible by negative 2? So factor out negative 2, and you get negative 2 minus the root of 3. Is that value going to be positive or negative? Definitely negative. 285 degrees. Which quadrant is that in? The fourth quadrant. Is tangent positive or negative in the fourth quadrant? It is negative. Okay, so I got a general idea that I'm hopefully on the right track. Cool example, huh? So we've done sine, cosine, tangent. Now let's end with the joyous proof problem. I know how much you guys love to do proofs. Now, those of you watching the YouTube video who are gone on the band trip or whatever, you're starting to shut down right now as soon as you see proof. Okay, you gotta like hold your horses. This is really actually a very nice proof. It works out. It's not bad at all. Okay, but and you really need to know it. We're proving a cofunction identity, and so you're not going to use these cofunction identities, but you are going to prove that some of them are true. This is if you take tangent of pi over 2 or 90 minus an angle, that's the same as cotangent of the angle. Huh, who knew? You know how I come up with them? We just do our sum and difference formulas. Now, before I do the problem correctly, I'm going to start it incorrectly so you can see the mistake that would develop. Tangent pi over 2 minus u. Would you agree that we have a difference formula for tangent? We do. And so we would say tangent of pi over 2 minus tangent of u over 1 plus tangent of pi over 2 times the tangent of u. There's only one issue with that. Anybody see it? What's the tangent of pi over 2? It's undefined. We don't know the tangent of pi over 2. It's undefined. Do we know the sine of pi over 2? What is it? 1. What's the cosine of pi over 2? So we really can't use tangent. We have to use sine and cosine. So therefore, the first step to this proof is right here. The tangent of pi over 2 minus u is equal to the sine of pi over 2 minus u over the cosine of pi over 2 minus u. Is everybody okay with the first step? Now I'm going to use my sum and difference formula. I'll do the top. Expand it. What do we got? Sine of pi over 2 times plus or minus sine of u Now I got to expand cosine. Cosine of pi over 2 times what? Cosine of u plus sine pi over 2 sine of u. Okay, now it's really important here. You guys just told me that we know the sine and the cosine of pi over 2. What's the sine of pi over 2? 1. What's cosine of pi over 2? 0. So we're going to substitute those values in. And what you get is 1 times the cosine of u minus sine of u times 0. Divided by 0 times cosine of u plus 1 times the sine of u. So what's going to happen? Yeah, the sine of u goes away on the top because it's times 0. The cosine of u goes away on the bottom because it's times 0. And we're left with cosine of u over sine of u. What's cosine over sine? Cotangent. Is that what we were trying to prove? Yeah, I mean, that's the nice thing about proof, right? Like, you know the answer. You know what you're supposed to come up with. That's the whole idea. Now, what's very important, one last step here, we've got to teach you guys how to end your proofs. Now, there's a Latin word, well, a saying, and it's the acronym is QED, and it's Latin for the acronym is Latin for that which was to be shown has now been demonstrated. So we wanted to show something, and we've now demonstrated it. So QED, nobody knows what it means. Like you write it, your parents see it, you're like, wow, QED, you must be really smart. You must be really good college. You know what I mean? Okay. Or here's another way you can end it. Okay. You can put a little box. I don't know why. I just saw a professor do it one time. Dot's like a period. I don't know. Sometimes people check their box, so it's like, okay, checked off my list. I had a professor once. His name was Professor Zorn. Professor Zorn, if you're watching, I'm sorry I didn't do better in your class. I really found it extremely interesting. He actually wrote our college textbook. Osby and Zorn right here. Yeah, calculus. He actually had a doctorate in both mathematics and in English. So when you would go through our proofs, he would verify that they're both mathematically correct and then grammatically correct. So we got writing credits for our proof courses because we wrote so much. But he would often get to this spot, and we would be wondering how he would end his proof, as though he would like come up with like some Greek acronym that meant something, and he would pause and he'd wait, and he'd read done, and that's how he ended his proofs. And I was like, "What are you waiting for, dude? Like, just write done." So I don't care how you end it. That's up. Sure, or QED, or a box. Maybe you want to make up your own symbol. Maybe you would like to finish your proofs by doing that. I don't know. Okay? I mean, come on, folks, right? As soon as we write cotangent of u, we know we're done, right? But the formality is just, you do whatever you want. It's free country. Okay? I'm just trying to have fun, so. All right. So how about an assignment, and then we can check up on your. So here's your assignment. You see it posted right here. 7.2, page 5, 48, numbers 1 through 8, 11 through 16, and 18 through 19. Have a great spring break. Try to keep up with your math, and we'll see when we get back.